Okay, so back over on the main site, let's go to install. Let's go to connect here. Okay, and we can see ESP32-S2 setting on COM7. And now it's going through the installation process. Isn't this just like so cool? You don't need to install Arduino. You don't need to do anything but simply run it from a web browser. Hey everybody, Michael Crump here, yet again talking about all of the latest and the greatest in PlayStation 4 homebrew news and much, much more. And so what this allows you to do is that it allows you to have a web installer for the modified version of the ESP32-S2 server that Stooge created. Now, if we go to this project, and I'm going to go ahead and open it up, you'll see that this is the 9.00 PS4 Jailbreak server that has some things already included in it, such as being able to have USB emulation built in. So basically what I did was I took this project and combined it with some of the work that Brian had mentioned in his video, which is just located right here. And his video was all about creating a simplified way to install ESP32.S2 bins to the device without doing things such as installing the Arduino IDE. And so basically I stood up this single page application which has simply a home, it has an install button, and then it has a couple of YouTube videos in case others stumble upon this GitHub page. And so as you can kind of read through here, it says at the beginning here that I've modified the base image with the following, and to keep in mind that the payloads are not included in this release, so they need to be added by connecting the device via Wi-Fi and navigating to the admin.html web interface. There is this one button that you'll need to click on, which is just simply connect, that will connect to your device as well as install the needed files. And then I have a couple of different videos down here in this last section in case you want to kind of get up to speed with maybe the ESP32-S2 to the Raspberry Pi Zero-W to the ESP32 and then finally to the ESP8266. And so if you simply want to just install this onto your device, then all you're really going to need is going to be a Chrome web browser, such as the one that I'm running here, a USB cable, and putting your ESP32-S2 into the programming mode. But if you want to learn how to build your own installer, well, the rest of this video is just for you. And another question that might come up is, does this work with other browsers? For the most part, you are going to need to use Chrome, as I just mentioned just a moment ago. It also appears to work over inside of Edge. But then in some browsers such as Safari and Firefox, you will see this message right here. And what it is basically stating is that your browser does not support the Web Serial API. This is the Firefox Developer Edition that I tried here, so your mileage may vary, but in the short term, I would definitely recommend using Chrome. And keep in mind that we are installing these files via a web browser, so the operating system that you're currently using doesn't really matter. This works with Mac OS, it works with Linux, and obviously Windows, which is what I'm on right here. Just make sure that you are using Chrome. Okay, with that being said, let's get into how you might would want to make one of these yourself, as well as some additional details to the thought process that I made when putting this together. So here we are, we're inside of the project, and inside of the project, if I scroll down just a little bit here, then you will see that I have removed the password. There was a password that was just set of password. I went ahead and removed that mainly because my ESP32-S2 device isn't connecting to my home Wi-Fi, so it really doesn't matter if someone else connects to it. The other thing is that the range for these access points, especially when you're running something like these ESP32 devices, is very, very, very limited, meaning that you can't even go to another room in your house and pick up this access point, much less if you were connecting from another house or your neighbor's house. The other thing that I did was down here with the wait time, I changed this to 3 seconds versus the 10 seconds that it was before. So down here in this code, you'll see that it has some checks that says USB wait time. If it's less than 5,000, then they just set it back to 5,000. So I commented that one out. The other one that was in here was that you set it to be greater than 25 seconds, then it would just reset it back to 25 seconds. For the most part, at least for this first initial image, those are the only two things that I changed. So if you're wondering how do I actually create the image, well, the very first thing that we're going to need to do is we're going to need to go up to File, and then we're going to need to go down to Preferences. And then right here where it says Show Verbose Output During, there's this check mark here that's simply on Upload. Make sure that you have that checked. So now if you go up to Tools, make sure you also have the right board selected. Again, these are the settings that I have been using with my ESP32-S2. So you can see my board is ESP32-S2 dev module. There is the upload speed. This next one is disabled, disabled, disabled. Internal USB is my upload mode. And you can see the rest of these values here. And then obviously make sure you have the correct COM port listed here. What you're going to do is simply come up here to upload and then press the upload button. And then down at the bottom, you'll see that it is compiling the sketch. Once it finishes compiling the sketch, then it's going to simply take that code and it's going to upload it to your ESP32 device. Now, what's going to be very important with this process is going to be looking at that verbose log and pulling out a section of text, because there's a couple of different files that you'll need, especially if you want to create your own web-based installer. It is starting the upload process. Everything is uploading properly now. Let's just go ahead and expand this window. And it is at 100%, so it has been uploaded. So let's scroll all the way back up to the top, and this line right here, copy it, and we are going to paste that into Notepad. Okay, there it is in Notepad, and I'm just going to clean this up and make it a little bit more readable. Okay, so what you see here is that we've got these 4 bin files, and then they also provide the offset right here. And so what we need to do is we need to convert the hex to decimal. And so here is one of the tools that will help us do just that. Again, this is one of the tools that Brian had mentioned, and I'm just going to use this same exact one. So let's take this value and let's just go ahead, paste it in here, and let's go convert. And here is the decimal number. And so I'm just going to go ahead and do that for the remaining of these 3 files right here. And I am done. And so here is the hexadecimal that has been changed to just the decimal for each of these 4 files. Let's go ahead now and let's copy these 4 bin files to a place that we can work with them. We can see that here is where at least 3 of the files reside. Okay, I'm inside of that folder, so I'm just going to copy these 3 files out. And then I'm going to paste these. And now we just have one more. This one is going to be living in this folder. So I'm going to go copy here. Here is going to simply be the boot_app0.bin. So we'll take that one, we'll copy it, and that will also go in this folder. Okay, so that is all of the files that we're going to need to copy over. Is you want to look and to make sure that the offsets match up to the name that was generated for the bin files. So if we wanted to check one of these, we could go to offset 4096. And again, this one is linking to ESP_server, ESP32_server_900U.ino.bootloader.bin. And again, you would want to put in the proper offset that you were generating yourself. Some of mine may work for you, so just keep that in mind. Let's take the next one here, which was our boot_app0.bin, which is located right here. And this one does match up to 57344. The next file here is going to be ESP32 server underscore 900u.ino.partitions.bin, which is this file right here. And this is 32.768. And then last but not least is the ESP32 underscore server underscore 900u.ino.bin, which is this file. And this also matches up to 65536. If all of that looks great and you have the proper offset as well as the file name, well, then you are ready to put it on the web. And in my instance, I just have a folder here that's called bins, and I'm going to go add a file and I'm going to go upload files. And I am dragging and dropping the 4 bin files that we just discussed into my folder. And I'm going to commit those changes. And if we go back into bins, then you'll see that we have all 4 of those bin files along with the manifest.json, which corresponds to those files as well as the offset. One other thing to note here is that there is an ability that you can add a new install prompt, and I've set this to true. If you turn this to false, then it will not alert the user that you're about to format their ESP32-S2 device. So definitely make sure that you keep this option in there because it's the user's device and you don't want to put anything on their device that they're not willing to install themselves. So I'm going to go ahead and go back to the root of this directory, and I'm going to go down to index.html, and I'm going to scroll down into this file. The main thing that you're going to want to make sure is included in this section right here calls out to that manifest. So here we have a manifest, and then it says bins, and then manifest.json. If you're using my template, then more than likely you're already in great shape. But I just wanted to call that out in case maybe you want to change the name or do something different with yours. Okay, the moment of truth. Let's go ahead and try it. Okay, so back over on the main site, let's go to install. And before we actually click on the install button, if you do have Arduino or you do have something like that that's currently running, then make sure you go ahead and close out of those applications right now. In my instance, I do have Arduino running, so I'm going to quit out of that application and make sure, of course, that your ESP32-S2 device is in programming mode. In my previous video, I talked about how you would do that. Let's go to connect here. Okay, and we can see ESP32-S2 setting on COM7. And we're going to go to connect, and we can install the ESP32-S2 PS4 exploit right here. And we can also take a look at the logs and the consoles if we wanted to. So let's go ahead and click on the install button. And there is that prompt that I mentioned just a second ago. And we can click on install here. Okay, now it's erasing. And now it's going through the installation process. Isn't this just like so cool? You don't need to install Arduino. You don't need to do anything but simply run it from a web browser. Okay, wrapping up. Okay, installation is complete. And one of the things to note here is that inside of this little pop-up, there is logs and a console that is available for you to view if you would like to. So it looks like you can download the logs. There's a reset device. I haven't tried this, so I'm not sure what all that it does, but there is something that maybe you could explore and play with if you wanted to. And then we can obviously go back. Okay, let's go ahead and let's give this a shot on our PlayStation 4. Okay, so let's go ahead and let's head over to our settings, back into network again, and then set up an internet connection. We're going to use Wi-Fi. We're going to custom. Okay, we're going to select the PS4_web_AP. Again, that was one of the modifications. There's no password. We're going to go to automatic here. Do not specify. We are going to set our DNS done. And we're going to go next. Automatic, do not use. And let's go to our user guide, helpful info. And let's go up to Gold Hen. And again, we won't have to do anything here. The USB emulation is completely automatic. And it was set at the 3-second USB timeout. So there we go. Golden 2.1.2 has been loaded. And so that is going to do it for today. Again, many thanks to Stooged and to Brian for putting in the initial groundwork of creating the Arduino image and then sharing this discovery of how you can install to these ESP32 devices through a web interface. So thank you so very much for watching, and I'll see you on the next one. Michael